Hi, my name is Brian and welcome to Rocket Walkthroughs. Today we will be building a simple Blackjack game. By now you should have forked and cloned the Blackjack repo and also read the game rules. If not, pause the video here and take some time to go and do it now.
Now go on and get.
So in this walkthrough, we will split the game into 4 parts. First, we will get a playable game with minimal functions where 2 cards are dealt to the player and dealer from a deck, and we can evaluate a winner from there. Second, we will add the ability for the player to hit and stand, and after that, third, we will also add the ability for the dealer to hit and stand. And last of all, we will add the variable value of ace, where ace can be either 1 or 11. Ready? Let's go! Let's start by pseudocoding together. For now, we will aim to create the minimum functionality of the game. First, we need to define the player and the dealer. Then, we need to create and shuffle a game deck from which we will then draw 2 cards for the player and the dealer respectively. After drawing the cards, we will check for win conditions right away. We can leave the hit and stand functionality to later because logically speaking, the win conditions are far more important because the game cannot conclude without them. Therein, we check if either hand has a blackjack and consider its relevant scenarios. And if there's no blackjack, we will evaluate the total value of each hand and compare to see who has the higher value hand. Doing this, we can evaluate the basic endgame condition without worrying too much about the extra functionality. As a final objective, we must be able to display the hands of both the player and the dealer in the output box and declare who the winner is. And now as we begin, we look at our pseudocode and we can identify 3 states that our game will be in. So first, our game starts in a default state as it loads on page. Second, the cards are drawn. And third, the results are shown. We shall also define the current game mode and set it to game start. Next, we need to define 2 more global variables that are our player and our dealer. More specifically, we're defining their hands so that we can manipulate the cards as the game progresses. The last global variable we will define is the game deck. Now that that's settled, you should already have the make deck and shuffle deck function in your script.js file. And in addition, we will make a function called create new deck that creates a shuffle deck. What we want to do is when we first press the submit button is to create the game deck, deal 2 cards to both the player and dealer respectively, progress the game mode, and then write and return an appropriate output message. Before this first submit button press, the game mode will be game start as we have defined in the very beginning. Let's write an if statement for this game mode. What this means is that when we load the page, current game mode is equivalent to game start. And when we push the submit button, the code that's in the curly braces after the if statement will run. Let's assign the output of the create new deck function to our global game deck variable. Let's test to see if that's working. We will see that the game deck is an array of 52 objects, 52 cards, and they have definitely been shuffled. Now that the deck is made, let's draw 2 cards for both the player and the dealer respectively. Let's pop a card from the game deck and push it into the player hand array. We will do this once more for the player and twice for the dealer. Let's check to see if the cards are successfully pushed into the respective hands. Now that we know that this part works, we want to make an output message to tell the user that their cards are dealt and that we can move on to the next state of the game. Let's update the game mode to game cards drawn. Then we create a variable called output message outside of the if condition because we will be changing this output message in the other game modes as well. Now at the bottom of the if statement, we will write a simple message and finally return it as an output. Let's test to see if our message appears in our output box. Alright, now that this first part is working, let's make things a little bit easier by clicking on these drop-down arrows to hide our finished code. The last output message tells the user that the cards are dealt and to click the submit button once more to evaluate the cards. So, for our next click, we want to first check for blackjack. This has 4 possible outcomes. Both the player and dealer has blackjack, and this will result in a tie. For 2 and 3, either the player or the dealer has blackjack, and either of them wins. Lastly, both do not have blackjack, and the game continues. Then, if there are no blackjacks, we will calculate the total hand value of both the player and the dealer, after which we will compare the total value of their hands. If both hands of the same value, it will result in a tie again. Otherwise, the higher valued hand will win. And like before, we will write the appropriate output message and change the game mode. Okay, and now to start coding, we begin with another if statement, checking if the current game mode is equivalent to game cards drawn. Let's wrap the curly braces for the if statement around the pseudocode for the second click. Now, we need to check for Blackjack. What we want to check is the possible outcomes with the implementation of the Blackjack functionality. We will create two variables to indicate if either the player or dealer has Blackjack. These variables will be booleans. We will also create a function to check for blackjacks. So now I'll create a new section for game functions for all the game logic that we will be coding. Let's think through this function. We want to check both cards in the hand for blackjack. We will return true if a blackjack is found and false if there isn't. Here, we'll create two variables for the two cards and access them from hand array. We will also create a variable called isBlackjack and set it to be false. This is because we will only change it to be true if there is a blackjack condition, and we will write the condition for that underneath. Then we will return isBlackjack. Back to the main function. We will call the function for both the player and the dealer hands to signify if player or dealer has blackjack. Let's test this out now. And now we want to code the possible conditions of blackjack. First, we check if either player or dealer has blackjack. Else, if neither player nor dealer has blackjack, we will calculate the total value of their hands. If either player or dealer has a blackjack, there are three possible solutions. If both players have blackjack, this results in a tie. If player has blackjack, the player wins. And if the dealer has blackjack, the dealer wins. Now let's write the appropriate output messages for these conditions and test if our conditions are correct by console logging the output messages. So now that our blackjack conditions are tried and tested, let's move on to the scenario where there is no blackjack. We first want to calculate the total hand value of the individual hands, then compare these values to determine the winner. And lastly, we want to write the output messages and display both the content of the hands as well as their total value. It sounds like a big bite, but every cake is eaten in small bits. First, let's make a function to calculate the total hand value of each hand. We'll call this function calculate total hand value. This function takes in a hand array as a parameter and will loop through the hand array and add up the various values in the hand. However, there are exceptions to the picture cards in Blackjack. Ranks 11 to 13, which represent Jack, Queen, and King, are valued at 10. We won't worry about the Ace for now. Now let's start coding. Let's start with creating a variable for total hand value and equating it to 0. Then we make a while loop that loops through the hand. Then we create a variable that stores the current card. We will add the rank of the current card to the total hand value. And if the current card is King, Queen, or Jack, the total hand value is increased by 10 instead of their own rank. Else, the card's rank is added to total hand value. Lastly, we will return the total hand value. Now, we can test if the function works by console logging in the main function. Great! Now we have a function that calculates the total value of an individual's hand. Now let's create variables that will hold the total value of both the player's hands and the dealer's hands. We can now start on the winning conditions. At this point, there are three scenarios: a tie, the player wins, or the dealer wins, after which the game mode will be updated. Now let's code out the three scenarios. If both player and dealer have the same total hand values, it's a tie. Else, if player total hand value is higher than dealer's, player wins. Else, dealer wins when both of the conditions above are false. Now let's test if our conditions are working. To test this out, we can hard-code the variables before our conditions for the total hand values. Great! We can now write the appropriate output messages and change the game mode to game results shown. Great! Now that we have a working game, we can start making our output messages nicer. Let's create a function that helps us to display the hands of both the player and the dealer. This function will take in two parameters, the player's hands and the dealer's hand. In this function, we will loop through each of the hands and display them in neat lines. We can do this by accessing the name and suit keys of each card object within the hand array and format the output. After which, we will call the function to return the formatted string into the output message. Let's also add this function to the output messages in the Blackjack checks. Let's test this out now. Awesome, it works. And now lastly, let's create a function that will display the total value of the player's and the dealer's hands. This function will take in two parameters as well, the total hand value of the player and the total hand value of the dealer. We will then use these parameters to add to our output message. Let's call this function and add it to our output messages. Nice! Everything is in place and our version 1 is complete. Now that the base game functionality is in place, let's implement the hit and stand logic for the player. Let's plan this out together. First, we will add an extra game mode, hit or stand. Second, we will implement the option for the user to hit or stand. If the user chooses to hit, we add a card to their hand. And if the user chooses to stand, we will compare their hand against the dealer. Alright, now that we have our roadmap, let's head for our first objective. First, we need to make a new global variable in caps again and assign it to the appropriate string. We're going to call it game, hit, or stand. Next, we go into the main function and look for the point in which current game mode equals game result shown. We're going to change this to current game mode equals game, hit, or stand. And now lastly, we're going to set up the new game mode block using another if statement like the game modes before. And we input if current game mode is equivalent to game, hit, or stand. Now, let's code the hit or stand functionality. This part is not too complex. We need to code two things, player hit and player stand. Let's get started by writing these conditions. If input is equivalent to hit and else if input is equivalent to stand. Let's code an input validation by making else return an output message that tells the user that anything other than hit or stand is invalid and requests the user to only input one of these two options. Next, under the hit if statement, it just means that the player draws one card. For that, we'll pop a card from the deck and push it into the player hand. Then, we'll set the output message to call the display hand function and inform the user that they have just drawn another card and ask them to input hit or stand. Finally, for the stand else if statement, we're going to copy the code we used previously for evaluating the two hands in the previous game mode and transfer it here. Let's test to see if our game flow works up to this point. Great! Everything for our version 2 is done. Give yourself a pat on your back. Alright, now let's give the dealer the ability to hit or stand as well. Let's plan this out in serial code. 1, we want the dealer to choose to hit or stand only after the player has chosen to stand. 2, let's make our dealer hit as long as their total hand value is under 17. And 3, once their total hand value is above 17, the dealer will then choose to stand. Alright, let's code this out now. We will code this functionality after the player inputs stand and after we calculate the total hand value of both hands. That's a while loop here. While dealer total hand value is less than 17, the dealer will draw a card once again by popping the card from the deck and pushing it into the dealer's hand. Then we will determine the total hand value of the dealer hand again to update the values. We don't need to write anything else because the loop immediately stops drawing cards after dealer hand total value goes above or equals to 17. Let's check to see if the dealer actually draws extra cards now. Great, the logic for the dealer is done and we're almost done with the base game. Yeah! Great job on making it this far. Now is a slightly tricky part. We want to add logic to determine whether aces should have a value of 1 or 11 for a given hand. As before, let's take time to plan this out. The logic is the value of ace should be 11 if the total hand value, including the ace, is 21 or below. But when the total hand value, including the ace, exceeds 21, the ace value must change to 1. Since this involves counting value, we can do this within the calculate total hand value function. To code this is slightly challenging to understand, but don't worry, we'll do this together. We first create a variable to keep track of the number of times aces appear in hand array. Let's call this ace counter and assign it a value of 0. Let's then add an extra condition to get the aces in the hand array. If there is an ace, we'll do two things. 1, add 11 to the total hand value, and 2, increment the ace counter by 1. Following that, we will create another while loop that loops ace counter number of times. We'll add a condition within the while loop that deducts 10 from the total hand value if it is more than 21. This way, we should be able to get the appropriate total hand value. Now, let's go through a scenario where the hand array consists of the cards ace, 2, ace, and 4. After the first loop finishes, the total hand value will be 28 and our ace counter will be 2. We then move to the second loop, which will run twice because that is the number of ace we have detected. On the first loop, the if condition detects that the total hand value is 28, which is above 21. Hence, it takes away 10, making the total hand value 18, effectively changing the value of one of the aces to 1. On the second loop, nothing will happen because 18 is under 21. Now that's done. Let's do a full test of our game. Amazing! It's all working perfectly. I really want to encourage you to try and play around with the code and to format your game output and flow to be even better than this now. Well done for making it all the way. Bye for now. I'll see you next time.